Good evening, everyone. Yesterday we did start up with module 3, wherein we have gone ahead and seen some of the concepts related to core of the embedded system, and I also began with another component used in embedded system, that is memory. In memory, we have gone ahead and seen the program storage memory, which is also known as ROM, read-only memory, and different types of read-only memory we did observe, and we have seen that types such as MROM, PROM, EROM, EPROM, and E square PROM, as well as NVRAM. So these were the types of ROM that we have gone ahead with. Today we will see the next classification of the memory, that would be your read and write memory, that is the RAM, and also some input output subsystems. There are some input output subsystem that is used in embedded system. We will go ahead and see some of the components in today's session. So let us begin with the second classification of memory, that is RAM, read write or random access memory, as known as. RAM is also called as a working or data memory for the processor or the processing unit that is being used in embedded system. That processing unit may be a processor or a microcontroller. So the controller or the processor can read or write the data into or from the RAM. It is a volatile memory. When I say volatile, that means that as and when the system is switched off, the storage or the information that is stored in the RAM memory is lost. So we call this type of memory as a volatile memory. So there are three different types of RAM that we'll be studying in this session: SRAM, DRAM, and NVRAM. In fact, NVRAM I have already completed while teaching you all ROM. So today we will see only SRAM and DRAM. Let us begin with the first type of RAM, known as static random access memory, or also known as SRAM. SRAM is the one that stores the data in the form of voltages, and that is this memory cell, SRAM memory cell, is made up of flip-flop, or we can also say that it is made up of 6 different types of MOSFET. You can see here there are 6 MOSFETs that are used, Q1 to Q6 MOSFETs that are used to make one memory cell of SRAM. Out of this 6 MOSFETs that are used, 4 MOSFETs, that is Q1, Q2, Q3 and Q4, are being used as latch. You can see that the latch, this one is an visualization of the SRAM memory cell. So latch, the 4 transistors are used as latch, and the other 2, that is Q5 and Q6, are being used as the controlling, is used as for the controlling access. So for read control and write control, this Q5 and Q6 transistors or MOSFETs are used. So in order to, how do I write? So you can see that there are bit lines here, bit line B, that is through Q6, and B bar, that is through Q5, and there is also a word line. So you can see there is a word line here. So if I want to read or write into this memory cell, then in that case what should I do? Now let us begin with what to do if I have to write into this memory cell. Now suppose if I want to write 1, so what I do here is the word line is asserted to high. Initially the word line is asserted to high, and then bit line B is made 1 and B bar is made 0. So I can write or write 1 into this memory cell. Similarly, if I want to write 0, then bit line B should be 0 and B bar should be 1. So this is how I do the write operation. Suppose if in order to read both B and B bar should be 1, and also the word line should be set to 1. That's how we go ahead and do the read operation in the SRAM. So, what is the disadvantage of SRAM here? Of course, the SRAM has very low capacity and is high cost. You can see that there are 6 MOSFETs used for building up one SRAM memory cell. So, obviously, the cost will be quite high, and also you can imagine that for one memory cell we are using 6 MOSFETs. Then if I have to have an array of memory cell, how many transistors do I need to embed into the silicon wafers? So that's the biggest disadvantage of SRAM. So to overcome this, they came up with another type of RAM known as dynamic RAM, dynamic random access memory. So here in dynamic RAM, the stored or the data is stored in the form of charge. So you can see that dynamic RAM is a single MOSFET along with the capacitor. The capacitor, as I said, the data storage is in the form of charge. That is because of the capacitor. Here the advantage is that we are having high density compared to high density, and also low cost comparative to SRAM. DRAM provides that. But the disadvantage here is because of the capacitor. Obviously, whenever we have a capacitor link, there will be a charge leakage. So the charge leakage problem is there in dynamic RAM. Hence, we have to have extra refresh circuit. It requires a refreshing on timely basis to overcome the leakage problem. So a refreshing circuit is an extra addition that needs to be added in along with the DRAM. So based on the concepts of SRAM and DRAM that we have seen right now, I have also given the distinguishing points between the SRAM and DRAM cell. Generally this is asked as a sub question with along with another main question. So you can expect around 2 to 3 marks allocated for SRAM and DRAM cell distinguishing or difference points. So you can see that SRAM made up of 6 MOSFETs, and here DRAM is made up of 1 MOSFET. Does not require refreshing. DRAM requires refreshing. Low capacity, more expensive SRAM, high capacity, less expensive DRAM. And SRAM advantage is that it is fast, whereas DRAM comparatively is slow in operation because it requires refresh requirements. So these are some of the difference point. So this completes our session on memory. So memory, ROM and RAM, this is what you will have to write in case if the question is asked on memory. The next is sensors and actuators. Here it's only about what is sensors and what is actuators. Sensors, obviously it's you all are aware because you've been using sensors in your many projects and everywhere. So here sensors is a transducer device that converts energy of one form into another form. And why this conversion is made? Generally it is for the sake of measurement or for some control operation. So that's all. That's about sensor. And actuators, yes, it's also a form of transducer device which can be either a mechanical or an electrical device. Here it converts a signal into a corresponding physical action. That physical action will be in the form of motion. So generally an actuator will be an output device. So this is the definitions of sensor and actuator, nothing more. Some examples you can give in terms of sensors, different types of sensors and actuators. Let us go ahead and see. So as I said, we'll next have a look at input output subsystems that are used in embedded system. One of the very popular input output subsystem that is used is LED, light emitting diode. You are very much familiar with LED as you have come forward. You have seen LEDs in many applications. Even in embedded system, LEDs are being used. So LED is used basically as an indicator. So it will be an indicator of maybe let's take an example. In case if you want to show that the battery is low or the battery is running low, then in that case an LED can give an indication of low battery. So basically LED is a PN junction diode. It's a simple PN junction diode which has an anode and cathode as two elements. Then we can directly interface LED with any of the port pins of a processor. But in case if an LED is connected to a power supply, then we'll have to add in a current limiting resistor in series with the LED anode, or it has to be in series with the LED anode or cathode, whichever is being connected to the power supply. So a current limiting resistor is required to be interfaced in series. There are two kind of configuration that can happen since we have two terminals, anode and cathode. In case if an anode is connected to the port pin directly, then the LED will glow in if logic 1 is driven at the pin, and if the cathode is connected to the port pin, if cathode of an LED is connected to the port pin, then LED will glow in case if logic 0 is through the port pin. Here one more point to be noted down is that when we are directly connecting a port or directly connecting a port pin or the LED to the port pin, then the brightness of the LED may vary according to the value that is being driven through the port pin. Whereas in case if the LED is driven through the power supply, that is the anode is connected to the power supply, then in that case the brightness will not vary and will get the required brightness as it will be a static power supply. So this is all about the LED. So you have a sample LED interfacing shown in the figure. Next component, we'll go ahead with a 7 segment LED display. This is also very popular, and you have seen lot of you have done experiments regarding say a 7 segment LED display in digital electronics, in microprocessor, so you know certain fundamentals. So let's quickly go through 7 segment LED display. This is basically used as an alphanumeric character display device, which has 8 LED segments. So you can see that 8 LED segment, A to G are the 7 segments that are used to display the alphanumeric character, and then there is a 8th segment known as DP, also known as decimal point. So in case if we want to display a decimal numbers, that a decimal point may be required, hence we have an 8th segment known as decimal point. How does it work? In case if I have to display a number 4, then I'll have to glow the segments F, G, B, C. Segments needs to be glowed. So there are generally there are 2 different kinds of configuration in 7 segment LED display, known as common anode and common cathode configuration. You can see the diagrams related to common anode and common cathode configuration. In common anode, of course, all the anodes of all the segments A to G and DP, all the 8 segments are clubbed together and shorted together, whereas in common cathode all the cathode terminals of LEDs, 8 LED segments are clubbed together. In common anode, let me take an example of a common anode configuration. Suppose if the common anode configuration is being used, then the anode is clubbed together and is connected to the supply, whereas the cathode will be connected to the port pins of a processing unit. All the 8 cathode will be connected to the port pins. It will be interfaced to the port pins. Now if I have to glow a particular segment, then the port pin that is attached with needs to be sent across a logic 0 in common anode configuration. This is all about 7 segment LED display. Next we will see another I/O subsystem used in embedded, known as optocoupler. Optocoupler is a device which is generally used to isolate 2 parts of the devices, the input and output part if we want to isolate. The circuit isolation is required. Sometimes we need to do a high voltage suppression, sometimes we need to suppress the interference that is coming up through the data communication. In such cases, optocoupler is the device which is being used for such requirements, like mainly it is being used for circuit isolation. Optocoupler generally consists of the package consists of a LED and a phototransistor. You can see LED and the phototransistor is combined together in a single package in an optocoupler. Optocoupler can be used in the input side of it as well as an output circuit. So you can see an input output circuit usage of optocoupler in this figure. Next we will go ahead and see two important another IO subsystem known as relay. Even relay you are familiar with. Relay is basically an electromechanical device. We are using the relay for path selector. It is used as majorly as a path selector for some signals or power. Relay consists of a relay coil. That is generally, you can see that the relay consists of a relay coil that generally made up of insulated wire, and then we also have an armature, and the contacts are connected to this armature. The working of the relay follows the electromagnetic principle. In case when a voltage is applied across the relay coil, current flows through the relay coil and the coil gets magnetized. So, the magnetic field is generated in the relay coil, which in turn attracts the armature of the relay and can move the contact points. So, it can move the contact points, and hence a path selection can be done of the signals because of the movement of this contact points. We can see in the figure there are three different configurations that are shown of a relay: single pole, single throw, single pole and single throw, which is an open configuration. This is a closed configuration. We can also have a single pole and double throw configuration. Single pole and a double throw configuration of relay coil is also shown in this figure. Generally a relay requires a driving circuit which is designed using transistors. So, relay is combined with a driving circuit, designed with a driving circuit is required for a relay. We have piezo buzzer. Piezo buzzer is also used as an indicator. We use the piezo buzzer as an audio indicator, in fact. So, we have two different types of piezo buzzer. Piezo buzzer can also be interfaced directly with the port pins. Even the relays can be interfaced directly with the port pins. That is one more point that you should remember. There are two different types of piezo buzzers. One is known as self-driving and the other one is external driving. What is the major difference between a self-driving and an external driving piezo buzzer? Self-driving piezo buzzer has a predetermined tone and it is a static tone. The tone does not vary, whereas external driving piezo buzzer the tone can be varied using the train of pulses. So, a varying pulse can vary the tone. So, the tone is controlled by varying the pulses. That is external driving piezo buzzer. Last circuit that we will be, or the last device that we will be going ahead in this session is the push button switches. The push button switch basically is an input device. We use push button switch as an input device. So, we have two different types of push button switch. One is known as, or two configuration, not types I would say, it is a configuration, two different configuration of push button switch, push to make and push to break. So, what happens in push to make kind of switches? The switch in push to make switch is normally in an open state. Switch is normally in an open state, and you can see open state, and if you want to make a circuit connection, then we need to press or push the push button switch. So, normally it is in open state, and to make a connection we have to press or push the button. So, that is push to make kind of configuration. Whereas push to break, what happens in push to break is that normally the switch will be in a closed state, Normally the switch will be in the closed state, and in case if I want to break the circuit, then in that case I have to push or press the button to break the circuit. So that is push to break kind of configuration of push button switches. Push button can be also used for generation of momentary pulses, and that's another usage apart from being used as an input device. It can also be used to generate a momentary pulse. Now how do we do it? The example of the pulse generation using push button is shown here in the figure. You can see there is a low pulse generator and a high pulse generator. A low pulse generator and a high pulse generator depends on the positioning of the push button. So where we position, so you can see that the positioning, if it is in between port pin and the ground, then it's a low pulse generator, whereas VCC and port pin, then in that case you have a high pulse generator push button. So the positioning of the push button switch can determine whether it's a low pulse generator or a high pulse generator. So even push button switch can be interfaced directly with the port pin. The uses of push button switches in the embedded system. Push button switches can be used, majorly push button switch, you can see that in an embedded kit it's used as a reset switch, and sometimes it can be also used as a start switch to start a system. Push button switch can be used, and of course as a pulse generator. So these are various different uses of push button switch in an embedded system. This is all about various IO subsystems that are present in embedded system, that are used in embedded system. In tomorrow's session or in the next session, we will go ahead and see some other components that are being used in embedded system, and we will learn some more components used in embedded system. Thank you.